Howdy. Our presentation is on the Eugene Island pipeline spill in Houma, Louisiana. This presentation was created by Anissa Aguilar, Amaya Guzman, Divya Shukla, and Cecilia Thornburg. The objectives covered in this PowerPoint include how the accident occurred, hazards that the oil spill presents to the community, tactics used to clean up the oil spill, and the aftermath of the incident and the cleanup process. On Sunday afternoon of July 26, 2009, 33 miles offshore and 60 miles southwest, a major leak was reported to the National Oceanic and Atmospheric Administration. 63,000 gallons of oil were released into the Gulf of Mexico by a major leak in the Eugene Island pipeline system. Prior to the leak, the Eugene Island pipeline system was known to be a major contributor and source of transport in several oil and gas industries. This 183-mile network of crude oil pipelines had the capacity to deliver approximately 200,000 barrels of crude oil daily, from developments in the central Gulf of Mexico to other pipelines and terminals onshore Louisiana. While the exact cause of the spill is unknown, potential sources of failure may be corrosion, metal failure, or the explosion of oil and trapped oxygen from oil rigs that may have accumulated in the pipes. Shortly before the leak, the Eugene Island line increased volumes of crude oil from Chevron Corps' Tahiti platform offshore flowing through the pipe, which may have led to increased pressure and risk for failure. Shutting down the pipe affected several oil and gas companies such as Shell, ExxonMobil, Marathon, Chevron, and ConocoPhillips. This image shows where the Eugene Island spill occurred in reference to Shell's Boxer platform and Chevron's Tahiti platform. The areas highlighted in red represent each seafloor pipeline.
I will be discussing the hazards that were presented to the community of Houma after the oil spill. Since the spill was in deep waters, far from shore, and the community was expecting calm weather conditions, officials did not expect the oil spill to affect the land community directly. The waterlife habitats were affected, and many birds and fish did die due to the contaminated water. Since the spill was in deep waters, though, there were no dead sea life that washed ashore. Boaters were asked to stay away from the contaminated areas so they would not carry the oil to other parts of the water or contaminate the efforts that the skimmers were making in the cleanup. The oil would wash on shore in forms of tar balls, but it did not stick to the sand or affect the community in any dire ways. In the first image to the left is what the crude oil looked like from above, and it seemed to have a rainbow hue and a sheen look. In image 2, it depicts how noticeable and big this spill was and how far it covered, as well as the skimmers controlling the perimeters of the spill.
So I'm going to talk a little bit about recovery after the spill. To begin with, the pipeline was shut down on July 25, 2009, and cleanup procedures were implemented. A damage reduction team was assembled with help from Shell, the U.S. Coast Guard, the Louisiana Department of Environmental Quality, the National Oceanic and Atmospheric Administration, the U.S. Minerals Management Service, and the U.S. Fish and Wildlife Service. The public was advised to avoid the area in order to minimize disruption to containment and removal efforts. An oil dispersant was used to the main body and leading edge of the spill via aircraft in multiple stages of roughly 200 gallons being dropped during each. Dispersants are used to break the oil up into small drops and dilute them into the water. This prevents the slick from reaching and damaging the coastal ecosystems. Drawbacks of this process include not actually removing the oil from the body of water and potential damage to the underwater ecosystem below. Dispersant is typically avoided when in close proximity to coral reefs. Skimming was also utilized to remove bands of oil via boat. Oleophilic skimmers were used to separate the layer of petrochemicals that float to the top of the body of water, and this is an effective method as it utilizes surface tension and the adhesive nature of oil, collecting 95% oil and only 5% water. The oil collected can be recovered and recycled. Weather conditions such as winds, currents, and storm chances were carefully monitored in case alterations in the procedure plans were needed to best protect the coast. On August 2nd, 2009, the spill response stage had ended, and this meant the oil levels had been observed at acceptable amounts and cleanup was completed. The pipeline will be cleared to restart function and following the necessary steps, repairs, and inspections. This slide includes images of both the aerial application of dispersant and skimming during the Eugene Island cleanup process.
As mentioned previously, by August 2nd, 2009, all response measures had been called off, and no identifiable sheen could be recognized by the NOAA and the United States Coast Guard. Because oil spills and dispersants may be potentially harmful to the quality of marine life, many of the members of the Louisiana community were concerned how this issue would be prevented in future cases. For this reason, the United States Coast Guard released a public report reassuring conservationists that through the inspection and repair process, their top priority resided with the health, safety, and protection of the environment. In addition, the cleanup process received positive feedback from Shell's incident representative. He reported that he was satisfied with the cooperation and efforts made throughout the removal process from the Unified Command and local authoritative officials. Once the cleaning efforts had concluded from the Eugene Island oil spill, officials reflected on the aspects that may need improvement in the event of another similar situation. According to the Department of Homeland Security, after cleanup, officials realized that the teams operating the aircrafts during the allocation of dispersants process had no way of communicating with each other or to the scientific support coordinator while in flight. The protocol they used was associated with the SMART Tier 1 data. This data is known as Special Monitoring of Applied Response Technologies, which provided a manual and guideline for how the cleanup process should take place. All in all, the cleanup process was ruled as a success, but it showed how real-time verbal communication in the aircraft dispersal would have benefited and the value and time of response.
This is our works cited page. And then here is our group charter contract that we filled out in lab with all of our signatures. Thank you.